Assalamu alaikum rahmatullah. I hope those are watching these videos from any corner in this world, you are doing great and having good health. And in this video, I'm going to explain the limiting reactant, which is the core issue of this chapter, the concept of mole. And you know that I am sequentially uploading these videos part by part, and right now this is something that is very common in your question paper. Students of English versions and O-level and even Cadet college, you know that when you see some questions from previous years, these questions is something very common. Whenever the questions come from the moles and about the chemical calculations, this is a common questions. And of course you need to learn it, you need to understand it, the basic. But this is very easy. The thing is that we just need to understand that the calculations, how to calculate the limiting reactant. The concept is when there is more than one reactant, it's not always possible to supply the required amount of reactant, because suppose in a place like nitrogen and hydrogen are reacting each other. So they will produce something. Suppose they will produce ammonia, or even that sulfur and oxygen is reacting and they will produce sulfur dioxide. So I am giving you some idea. Or you can say that even carbon and oxygen is reacting each other and they will produce carbon dioxide. Suppose we are taking example as of 3 reactions. So in these 3 reactions we can see that everywhere there are at least 2 reactant. When there is more than 1 reactant, then of course it will not continue till whole life. It will definitely end, and that end will be the responsible for any of them. I mean, among the amount is given in this reactant, any of reactant will end by itself, and that reactant is called the limiting reactant because it's limiting the reactant, because it will be the reason of ending the reactions. And we will be focusing on finding the limiting reactant as it is the amount of something. It's like the mass of any reactant that will be the reason for the ending of reactions. So if we just think about the definition, simply that the reactant that finished itself. So which will be the finishing factors first? So the reactant that finished itself during the reaction, it's called the limiting reactant, or I just write the LR. So very simply the definition is the reactant that will finished by itself during the reactions or chemical reactions. This is called the limiting reactant. Now you need to think how to calculate this thing, and that is the main issue. Suppose like it's given that 50 gram nitrogen is reacting with 5 gram hydrogen. If this is the question. Oh, before going to say that, what limiting reactant tells us what? 3 things. Limiting reactant tells us that how much reactant is reacting in the chemical reaction. Limiting reactant will also tell us that how much residue will be there. And of course, the limiting reactant will also tell us that how much product will be produced. How these 3 things will be measured and coming up with the idea. Let's talk about this. Suppose the question is that 50 gram nitrogen is reacting with 5 gram hydrogen. If this is the data is given, then how we will think about it? Suppose I am erasing other 2 reactions. And you know that as nitrogen and hydrogen is reacting, in this calculation of limiting reactant, we definitely need to balance the atoms number of reactant and product. First thing, we need to make a chemical balancing, reaction balancing in between the product and the reactant. Now, if we definitely we need to provide equal sign in between this reactant and product. Now we see that atom number is not same, so we need to put 2 here as hydrogen becomes 6 and here nitrogen is 2. So now it's actually done. I mean, the limiting reactant, for finding the limiting reactant, the first task is that we need to understand the reactions. We need to understand that how much molecule of reactant will be there, because we need to make it equal. And now we will think about the molecular mass of the reactant. So as we know that as nitrogen is 14, so this is times 2, which is 28. And here we see that this is 3 times 2, that is 6. And 6, hydrogen is 1 times 2 and 3, so it's all 6. And nitrogen is 28. And as we just find it out, the equal balancing in between reactant, now we see that if it is gram and it's gram, we will have a standard equation right now that this 28 gram nitrogen is reacting with 6 gram hydrogen. Okay, now we need to find out that then 50 gram nitrogen will be reacting with how much hydrogen. So if this is my standard equations, if this is my standard line that I will be thinking, then now we think that 1 gram nitrogen will be reacting with 6 by 28 gram hydrogen. And now you think that 50 gram nitrogen will be reacting with how much hydrogen? So it would be like 6 times 50 by 28. So if we divide 300 by 28, we will have the 10.71 gram. 10.71 gram hydrogen is required. Now you think that from where I'm just taking this data? I'm taking this data from the reactions. At first we need to make balance in between these two, product and reactant. And then we just calculate the molecular mass. And then we make an equation that, okay, 28 gram nitrogen is reacting with 6 gram hydrogen. This is my standard line. So now 50 gram nitrogen is given. So 50 gram nitrogen is reacting with 10.7 gram. That means this amount of hydrogen is required. But you see, there is only 5 gram. Now you think which reactant will end first. So as 50 gram nitrogen is already there, to react completely with 50 gram nitrogen, at least 10 gram hydrogen was required, but here only 5 gram hydrogen. So 5 gram hydrogen, so the limiting reactant is hydrogen because it will end first. So how much reactant is reacting? So only here 50 gram nitrogen is already there, but it was required 10.71 gram hydrogen should be in the reactant so that it will be like equal, but no. That is why hydrogen will end first, and right now hydrogen is the limiting reactant. But if we do it in a reverse way, suppose how? If I say that 6 gram hydrogen is reacting with 28 gram nitrogen. So 1 gram hydrogen is reacting with 28 by 6 gram nitrogen. So there is even like 5 gram hydrogen will be reacting with 5 times 28 by 6 gram nitrogen. So as 6 gram hydrogen is reacting with 28 gram nitrogen, I am taking it as a standard, just reverse. So 5 gram hydrogen is given. Now I think that 28 times 5 divided by 6 is about 23.33. That means 23.33 gram nitrogen was required to react with 5 gram hydrogen. But you see, so 5 gram hydrogen will end when it will react with 23 gram nitrogen, but 50 gram nitrogen is given already in the data. So how much nitrogen will be left? So the residue is nitrogen. So the residue would be the residue would be like 50 minus 23.33, this would be like 27.67 hopefully. So this 27 gram nitrogen will be the residue. So the answer is how much residue will be in the reactions? In these reactions 627.6 gram nitrogen will be residue, because this 5 gram hydrogen will end reacting with 23.33 gram nitrogen. But here 50 gram nitrogen is there. Again, this calculation is also said that how much product will be produced. How? When we need to find out that how much product will be produced, we need to find out the limiting reactant first. So as we find that this 5 gram hydrogen is the limiting reactant, as because this 5 gram will end when? With the reaction is 23.33 gram. So 5 gram hydrogen will be end, and that is why hydrogen is a limiting reactant. Now if the question that 50 gram nitrogen and 5 gram hydrogen, if they are reacting, then how much ammonia will be produced? Then for finding this answer, we need to find what is the limiting reactant. And as we find that hydrogen is the limiting reactant, now next level play. Then we need to think that here is given 6 gram. As we need to find out the amount of ammonia, then this is 2, nitrogen is 14, hydrogen is 3. So it is altogether 17 times 2, and this is 34. Right now we say that 6 gram. Now I will take about hydrogen as because I know that this is the end product. So 6 gram hydrogen is producing 34 gram ammonia. Okay, so 1 gram hydrogen is producing 34 by 6 gram ammonia. So 5 gram hydrogen was asked. So 5 gram hydrogen will produce 34 times 5 by 6 gram ammonia, and this is 34 times 5 by 6. 34 times 5 by 6 is 28.33. That means 28.33 gram ammonia will be produced if 50 gram nitrogen and 5 gram hydrogen is given. How I am doing it and why this 28 gram comes out? Because I am taking it hydrogen as a standard, because I know that hydrogen will end. So 5 gram hydrogen will produce this amount of ammonia for sure, because I am taking it as a standard value. But if you started from this way, the 28 gram ammonia will produce 34 gram, 28 gram nitrogen is producing 34 gram ammonia. So 50 gram nitrogen will be producing what? That is not the equation, because here nitrogen is not the limiting reactant. Hydrogen is the limiting reactant. So that is why we can do it here. So see that how the limiting reactant will tell us that how much reactant is reacting, how much residue will be produced, and how much production will be produced. And that is the beauty of doing mathematics in chemistry, especially in case of molarity and limiting reactant. So I am giving you a single example, but whenever you open a questions, you see the number of examples of limiting reactants. Suppose if say that like 50 gram, or even like if the question is that okay, 500 gram sodium hydroxide is reacting with 500 gram hydrochloric acid. Suppose this is the questions, like okay, sodium hydroxide is reacting with hydrochloric acid. Very simple. So what would be the product? We know this is a base and this is an acid, so it will produce, it's a neutralization reaction, it will produce salt and water. So simply it's a very well known equations. So it's sodium chloride and water. Now you think that The question is given that if 500 grams sodium hydroxide is reacting with 500 gram hydrochloric acid, then what is the next question? Like, if this is the question, how much reactant, how much residue, how much product? If the question is 500 gram sodium hydroxide, 500 gram hydrochloric acid, so it's given. Now this is your data, and now you find it out the molecular mass. Sodium is 23, oxygen 16, hydrogen 1, so it's together 40. You are just calculating the molecular mass, and here hydrogen 1, chlorine 35.5, which is 36.5. Now I am giving you a tricks. You think about it. Simply, before calculating, 40 gram sodium hydroxide is reacting with 36.5 gram. So if 40 gram sodium hydroxide reacting with 36.5 gram HCl, simply this 500 and 500 would not be same. That means more sodium hydroxide is required with comparatively less amount of hydrochloric acid. I'm not doing the calculation, I'm just giving you a hint to think about it. So if 1 gram sodium hydroxide reacting with 36.5 over 40 gram HCl, now you think that 500 gram sodium hydroxide 36.5 times 500 over 40. Now you think it will be very close to 500 again. So 36.5 times 500 divided by 40 is actually 456.25. So you think 456.25 gram HCl. Okay? So now you think that this 500 gram sodium hydroxide will be end after reacting with this amount of HCl. Okay? But 500 gram HCl is already there. So HCl would be the residue because 500 gram sodium hydroxide is already reacted. So 500 gram sodium hydroxide will be end after reacting with 456 gram HCl, but there are 500 gram HCl was present considering my data. So here this sodium hydroxide is the limiting reactant. It will end because this 500 gram will end after reacting with less than 500 gram. So the residue would be, in this case, 500 minus 456.25, and it will be like, okay, 500, it should be like 43.75 gram HCl should be the residue. That means HCl didn't finish. Sodium hydroxide was finished because 500 gram sodium is reacting with 500 gram hydrochloric acid. I was just giving you an idea that 40 gram will be finished after reacting with 36 gram. That means if 40 gram was given as equal, then 40 gram sodium hydroxide will be finished, but chlorine would be the residue. So that is why when 500 was given, so 43.75 gram hydrochloric acid will be the residue. And now as you know that sodium hydroxide is limiting reactant, and if the question is how much salt will be produced from 500 gram, now you think this one. So then you say that 40 gram sodium hydroxide is producing, then we need to think this is 58.5. Then we will say, okay, so 40 gram sodium hydroxide will be producing 58.5 gram salt. So 500 gram will be producing how much? That would be the answer. That is. So I think it's not much complex, but if you are watching this video total time, now I'll request you that make some problems in your minds and then solve it. And then the techniques that I'm just giving you, the idea that how to find the limiting reactant when the data is given, then first thing that you need to do is the chemical balancing, the reaction balancing. Make the equal atoms in all cases, then count the molecular mass and then do it accordingly. So I hope you understand, and it's not much complex. And I'm saying again that this question about limiting reactant is always common in the question paper. Do not miss, do not skip any part of limiting reactant. So see you on the next class. Stay well, stay blessed. Bye.